Hello students, welcome to the second part of algebraic expression and formula. So in this particular video, we are going to focus on simplifying expression and expansion by applying distributive law, including the quadratic expression. So the first example, we have 2 multiplied by 3y plus 7. So the expansion works in this manner, right? So the 2 is distributed using the distributive law to both the terms that's inside the bracket. So this will result in 6y plus 14. Okay, so same idea. What happens if the values are negative? Well, if the values are negative, then it will be negative 5n times 2, which equals negative 10n. And here is where we got to be careful, right? Because it's a common mistake to actually mishandle the negative sign. So in this case, it is a negative 5 multiplied with a negative 3n, which has given us a positive 15, right? And then n times n is n squared. So that's why we got to be careful here. Okay. Now next example. It is 5 subtract, right, or 5 minus the bracket. So in this case, we got to be careful as well, right? What happened is the negative. Okay, you can imagine that it is actually a negative 1 over here. So a negative 1, where we distribute in, okay, we have to apply the negative correctly. So negative 1 times negative 6 plus 6x, right? And then negative 1 times positive 2y is negative 2y. And that's the simplest form. Okay. Moving on to the next example. Okay, this one slightly longer example, but using what we have learned previously, we can work it out properly, right? We have x plus 3 times 2x is 6x. 3 times negative 3y is negative 9y. 3 times z is positive 3z, right? Plus 7z. So once we have that, let's put the like terms together. 7x's, negative 9y's, and 10z's. There we go, right? Okay, next example. This time round, they want us to expand and simplify the following expression. So once again, got to be careful here because it's a negative 2 right here, right? The negative 2 is, oops, I meant to use the highlighter, right? We got to be careful about this negative 2 over here. So let's be careful. We do that. 6x plus y. This part here do not need to do any operation as of yet. So negative 2 times 3x gives us negative 6x. Negative 2 times negative 4y is a positive 8y. And negative 2 times positive 3 is a negative 6. So from here, 6x minus 6x, we do not have any more x's. Then we have 9y's. And then we have 6 on this one. So that's the simplest form. Okay. Moving on to example B. Well, over here, we distribute the 4 in. So we have 4a minus 12b. And then once again, this is negative 5 multiplied by a, negative 5a. Negative 5 times negative 3b is positive 3b. 15. Let me write that properly. 15b. Put them together, we have negative a plus 3b. Okay, next example. So here we have nested the brackets. Well, same idea. Why is it blur? All right, so here you go. We have 2 plus, right? So we distribute the 3 in, there is 3p plus 6q. And we distribute the negative 1 in. So negative 3p minus 6q minus 2. Right? Simplify as much as we can first. So we will have 3p minus 3p, 6q minus 6q. We end up with negative 2. So this will give us 2 minus 2. And the solution is 0. And yes, 0 is a possible solution, right? Okay, next example. right? We have this one, expansion. So expansion, what do we do here? Okay, so we have 7m multiplied by n, right? We have 7mn. Okay, now if you have difficulty figuring out how this thing works, okay, let's just show you very quickly. You can use a window like this to help us, right? So we have 7m plus 3, and we have n minus 3p, right? So from here, we have actually 7mn. That's the area, right? So over here, we have 3n. Over here, we have negative 21 np. And over here, we have negative 9p, right? So that's how we can continue. So we have plus 3n minus 21 mp minus 9p. Okay, is this the simplest form? Yeah, it's the simplest form. Okay, so moving on to the next example, same scenario, right? If I were to just draw very quickly, you can see what's going on. We have 2a minus b over here. We have x minus 6y over here. So this give me 2ax over here. The over here will be negative bx. Over here is negative 12ay. And over here will be positive 6by. Right? So putting them together, this is what we'll get. We'll get 2ax minus by minus 12ay plus 6by. So you get a hang of it after a while, right? Okay. So in this case now over here we can actually apply what we call the algebraic identity. Okay, but either case, have I taught algebraic identity in class? Well, we can apply, right? So in this case, you can use more than one method, but what we do here is we can have 3a squared plus 2 3a 4b plus 4b squared. Okay, if you're not sure, this is known as the algebraic identity or quadratic. You can check it out. Okay, so you end up with 9a squared, right, plus 24ab plus 16b squared. Okay, example D, similarly we will apply the quadratic identity. So this is 9 squared minus 2 9 m plus m squared, which will result in 81 minus 18m plus m squared. Okay, moving on to question 4. Question 4, we have fractions, and they want us to express each of these as a single fraction. So what do we do here? Okay, so from here, let's write them in the form that's easier to handle. This is actually the same as writing in this manner, right? So half x is the same as x over 2. So once I write it in this manner, what we can do is we want to make the denominator to be common. In this case, the common denominator can be 10, right? So that gives us 5x over 10 plus 4x over 10. Okay, so result 9x over 10. Successful. Okay, next example. Okay, similar idea. We have 2h over 7 minus h plus 1 over 7. Okay, this will result in 2h minus h plus 1 over 7. That will be 2h minus h minus 1 over 7. And the final result, h minus 1 over 7. Okay. Next one, we have this situation. So once again, make the denominator common. Okay, so in this case, I can make the denominator 10. So what do we have here? We have 2, 4x plus 1, right? Plus 5, 3x minus 1 over 10. So that will result in 8x plus 2 minus 15x, plus 15x, minus 5, right, over 10. That will simplify to 8 plus 15 is 23x minus 3 over 10. All right. Okay, moving on to the next one. So over here, we have the denominator 4 and 6. We can make them both denominators to be 12, which is the LCM of 4 and 6. So we will multiply by 3 on this side, 3y minus 1. And then on this side, we'll multiply by 2, right? So 2y minus 3. Well, let's not forget the denominator. The denominator has to be there, else they are not equal, right? So the denominator in this case is 12. That will give us 9y minus 3 minus 4y. Minus 2 times minus 3 or negative 2, negative 3, be careful, right? It should be a positive 6. It's a common error that some students will make, so be careful. Okay, you simplify this, you get 5y plus 3 over 12. Okay, right, next example, we have question 5. This time round, we have something more complicated, but, okay, we can still work it out in the same manner, right? Same concept. So in this case, I will make the denominator all to be 6. So 1 is going to be 6 over 6, right? Minus x plus 3. Well, it's good to actually have it in parentheses so that you see where we are going with this. Okay, plus 5. All right, let me correct that. Oops. Eraser. This is 6. And I need to multiply with 2. There we go. Right? So let's do it one shot. Well, this third term here, we do not need to make any changes. It's fine. Okay. So from here, we can simplify. It will be 6 minus 2x minus 6 plus 15x plus 20. Let's not forget the denominator. It has to be there. And when we simplify that, we have 13x plus 20 over 6. Right? Final example of this particular assignment. We have a pair of shoes. You are given the cost 4x squared minus 9 and the bag 2x squared minus 3x plus 5. Find the total cost of 5 such pairs of shoes and 4 of the bags. Okay, so the total cost is 5 times, right, 4x squared minus 9 plus 4 2x squared minus 3x plus 5. That's fine, right? Not very complicated. So we'll simplify this. This will give us 20x squared minus 45 plus 8x squared minus 12x plus 20. We simplify this. This will give us 28x squared minus 12x minus 25. Right? Is this the simplest form? Yes, it's simplest form. So putting the unit and the parentheses so that it's neater. Okay? So with this, I hope you have been successful. Okay, all the best. Have a nice day.